if you're going to add or subtract two fractions, the most important thing you have to look for first is common denominators. We need to get both of the denominators of the fraction to be the same. And for these two fractions, they both have a denominator of 12y squared. So these two fractions already have a common denominator. That makes our job a lot easier because our resulting fraction is going to have that same denominator of 12y squared. And the only thing we need to do is add or subtract the numerators. In this case, I need to take 4x plus y and subtract 4y plus x. Now, truthfully, if you write this, it's wrong because you're not just subtracting the 4y, you're subtracting 4y plus x. So make sure you put parentheses in there. Now we'll distribute that negative sign through that set of parentheses. So we'll subtract 4y and subtract the x. Still have the denominator 12y squared. And combine like terms. In the numerator, I have this 4x and minus this 1x. So 4x minus 1x is 3x. And when I look at the y's, I got 1y here, and I'm going to subtract 4. So 1 minus 4 is negative 3y's over 12y squared. The last thing that we have to do as far as trying to simplify this fraction is to see if there's any common factors that can cancel. And when I look at the numerator, both of those terms have a 3 in it, so I could factor the 3 out, and I'm left with x minus y. In the denominator, that's 12y squared. 12 happens to be 3 times 4. So the 3 that's in the numerator and the 3 that's a factor in the denominator, those two cancel, and we have our simplified answer of x minus y over 4y squared. In part B, again, we want to add these two fractions. So the first thing we need to look for is getting a common denominator. Now, when I look at the two denominators I have, x minus 5 and x plus 6, they are not the same, so we don't have a common denominator. But we should think about what should our common denominator look like. It needs to have a factor that is x minus 5. And it also needs to have a factor that is x plus 6. So what I'm going to have to do is go back to the original problem, this 2 over x minus 5. Its denominator already has the x minus 5 in it, but what it's missing is the x plus 6. So I'm going to multiply this fraction by x plus 6 over x plus 6. When I multiply by a fraction with the same numerator and denominator, in essence I'm multiplying by 1, and I don't change anything. I don't change the value of the fraction, even though the fraction is going to look different. What that means for the resulting fraction is in the numerator, this part is going to start with a 2, but I'm going to multiply it by that x plus 6. And let's take a look at what happens when I move on to the 4. Looking at the denominator of this second fraction, it has an x plus 6 in it, but I want to turn it into a fraction with x plus 6 times x minus 5. So I'm going to multiply the numerator and the denominator both by x minus 5. Now I have that denominator, this is x minus 5 times x plus 6, and my numerator turns into 4 times x minus 5. Now we have the common denominators, and it's all about simplifying the numerator now. So I'm going to go ahead and take this 2 and distribute it into this binomial. So we'll have 2x plus 12. Then I'll move on to the plus 4 and distribute that into its binomial. So plus 4x minus 20. And my denominator stays the same. I'm not even going to multiply this out. I'll just leave it factored. Go ahead and combine like terms in the numerator. There are 2 x's over here and 4 x's over here, so I make 6 x's altogether. And when I look at my constant terms, I got plus 12 minus 20, and 12 minus 20 is negative 8. My denominator is still x minus 5 times x plus 6. You could try and factor the numerator. I know it's not going to go anywhere, but they are both even, so I could factor out a 2 and be left with 3x minus 4 over x minus 5 times x plus 6. And looking to see if we can cancel anything, none of those factors are the same, so there's no canceling that can happen. And this would be our simplified answer, actually leaving it as either of these last two lines, the 6x minus 8 or factoring out that 2, either one is the correct answer. You leave it either way and it'll be right. The third one, 7 over x times x plus 1 plus 3 over x times x minus 2. What we should think about first is our common denominator. Right? And if the common denominator that I'm going to have, will have to have factors of x and x plus 1 in it. So x and x plus 1. It will also have to have factors of x and x minus 2. Well, it already has the x, so I don't have to worry about putting that in my common denominator. However, what's missing is the x minus 2. Now, go back to that first fraction. That one with a 7 in it. When I look at its denominator, it has the x and the x plus 1. What's missing is the x minus 2. So I'm going to multiply the numerator and the denominator by x minus 2. Which means 7 gets multiplied by x minus 2. And when I move on to the 3, the denominator of that second fraction has an x and an x minus 2 in it. What's missing is that x plus 1 that's in the middle. So I'm going to go ahead and multiply this fraction by x plus 1 over x plus 1, which means 3 gets multiplied by x plus 1. Now it's all about simplifying the fraction that we have set up. Distribute the 7 to 7x minus 14, and distribute plus 3 into plus 3x plus 3. And we'll go ahead and leave the denominator factored. I'm not going to require that you have to multiply this out on the test or anything. Finally, combine like terms. There are 7x's plus 3x's make 10x's, and minus 14 plus 3 is minus 11 over x times x plus 1, x minus 2. Since we can't factor anything out of the 10x minus 11, and there's not a 10x minus 11 in the denominator, nothing can cancel, and this fraction's done. In part D, when I look at those two denominators, they're both unfactored quadratics. So before I even get started, I'm going to factor these two denominators. X squared plus 2x minus 8, that factors into x plus 4 and x minus 2. For the x squared minus 16, that's going to factor into x plus 4 and x minus 4. Now that I have those denominators factored, we can think about what is going to be the common denominator when I'm all done. And my common denominator has to have both of these factors in it. So it'll have to have x plus 4 and x minus 2. My common denominator will also have to have x plus 4 and x minus 4 in it. I already have the x plus 4, so I'll still need to multiply by x minus 4. Going back to the numerators now, for this 5, its fraction has x plus 4 and x minus 2. What's missing is this x minus 4. So I'm going to multiply numerator and denominator by x minus 4. Which means this 5 is going to get multiplied by x minus 4. And we'll move on to the minus 1. Its denominator has x plus 4, x minus 4. The only one that's missing is this x minus 2. So I'll go ahead and multiply numerator and denominator by x minus 2. And now we'll have common denominators, so this 1 has to be multiplied by x minus 2. Now that everything is set up, it's all about simplifying. My solution is going to have x plus 4, x minus 2, and x minus 4 in its denominator. The numerator, when I distribute the 5, is going to be 5x minus 20 minus, and distribute the 1, minus 1x, and minus 1 times minus 2 is plus 2. Combining like terms, 4x minus 18 over my factored denominator, x plus 4, x minus 2, and x minus 4. You can try and factor the numerator, but I know that this thing is going to turn into 2 times 2x minus 9. And I know that there's nothing, neither of those two factors are going to cancel with anything in my denominator. So it's not necessary to go ahead and factor it. We just leave our solution as 4x minus 18 over those three factors of x plus 4, x minus 2, and x minus 4.